We'll get to it. All right. Today we have a few notes to take today. I'm going to kind of do the same thing I did yesterday. Just take a few notes here in the beginning. Give you about 20 minutes today to work on your assignment. The assignment that I assigned the other day was page 541. That's due tomorrow. Keep that in mind. Now, the good thing is you're not doing any proofs on that assignment. What we're doing on that particular problem is, those problems, I should say, a lot of the problems are finding geometric mean and or finding an altitude and or a lag. So make sure that, whatever picture I give you, you can find the parts. So once I'm done with my notes, I only have a select few slides I want to go through. Not all of them, I have a ton of slides on this thing. Then what we'll do is right after we're done with this, I'll give you a little bit of time where you can actually work. I do want to go through one example though of your homework just to make sure you have the formulas on the board once we're all done here. But I only have a couple slides. It's going to be basically Pythagorean Theorem, do a proof, all that kind of good stuff. So it's pretty straightforward. I have kind of the outline on the board what I want to cover, but there's only a select few things that I actually want to do here. So let's see. Let's see if I got the slideshow taken care of here. Okay, let's go through this. Again, I'm only doing a select few slides today. So, first and foremost, goals today, talk about right triangles, do a couple of vocab words, which is basically the type of triangle we've been working with since chapter 8 here. We're still in chapter 4, so keep that in mind. We're still in chapter 4. It's just that we've skipped to a couple sections of chapter 8. We're going to finish up the sections of chapter 8 probably maybe Wednesday, Thursday this week. We'll kind of see how that goes. And then I want to start reviewing for the test as early as Friday this week. That's kind of the idea. Then next week at some point we'll have our test over it. I will give you a practice guide. I was thinking about probably giving you a practice guide maybe even as early as tomorrow. That way you have it in your hand. You have it for about a week or so. I think we don't have school next, Tuesday? Wednesday. So I got to kind of play by ear what day I want to review so that we don't have to put a test like right after that or right before it. So I want to make sure that you kind of know that. So I don't know how long the test can be. I'm going to kind of figure that out tonight to see exactly how long I want to make it. I think it's just going to be like a one-day test kind of a thing, because I just want to put a couple problems on there where you can prove that you know how to find legs or altitudes and stuff. So I'll explain it once we get there, and I'll tell you how many days you're going to get for it. Okay, vocab, that's our first part today. Theorem 8.4 is our main theorem today. That is the Pythagorean Theorem. It's the most famous theorem in math, for geometry anyway. It's kind of the main one that I want to cover. It's pretty straightforward. You've already seen it. Most people know the theorem itself. You know how it works, but I do want to show you where it comes from. And it's actually based on the work you're doing now on this assignment. That's what a lot of people don't know. That's why the formulas I've been giving you are so important. So we're going to do two proofs. I put a plural there, S. There is two proofs of this. One is actually using your math. That's why this math I'm going to show you today fits perfect. It's like an example of one of your homework problems. So it's great. And then the second proof is completely different. I have a nice little video you can watch, which is like a minute long, that shows the proof of it. And it's not like an actual YouTube video. It's like an actual animation. It's like a GIF almost. Okay. All right. But that's kind of the idea. That's what I want to cover today. Once we're through that, I'll give you time where you can just work on your assignment and you have the rest of the class. So it's pretty easy, but you do have some notes taken. Then I'll give you about 20 minutes. Okay? All right, let's jump right in. Right triangles. Here's the vocab terms I want to talk about. Obviously, on a right triangle, they have a right angle, right? Duh, has to have that. That's what makes it a right triangle. One of the angles has to be 90. The big idea here is when you have your right triangle, you can manipulate it. You can move the triangle around, and you can put the 90 degrees wherever you want. Like if I was looking at that picture for your homework today, if that was my triangle, I would turn my book so it wouldn't look like this. That's what I was trying to explain to you yesterday. Because I want the pictures to look like my pictures I've been putting on the board so you know how the formulas work. Okay? But again, there is more vocab words with this picture. So one of the vocab words is leg, the other one is the hypotenuse. Now obviously we've also been talking about an altitude. Altitude is how tall something is. There is multiple altitudes. That's actually a word we're going to look at tomorrow to show you the time from the homework to the stuff we're doing now. But these are the two main words you should know up till now. We've actually used these words a lot in chapter 4 as well. Legs, so let me give you the picture here. Legs are the two parts here. Now, for the Pythagorean theorem, they call them A and B, and I don't care which one is A and which one is B for the formula we're about to see here in a little bit. But how I know these are the legs, they touch the 90-degree marker. The hypotenuse is the long side. It's the only wall that does not touch the right angle, and they usually call it the letter C for this formula that we're going to use. So A, B, and C. And they can be any size, but the hypotenuse has to be the big one. Okay? All right, now, again, like what I was talking about earlier, you can rotate these pictures. You don't always have to look at a right triangle like that. Most people, like when they want to draw one, that's what they draw. But again, you can turn it like that. You can like rotate it. The legs are still touching the 90-degree angle. Those are still A and B. The hypotenuse is still that big side. So you have to be able to kind of identify that. And that's what I was trying to explain yesterday. Turn the page, so that's what your triangles look like. So they always look like the formula I've been giving you. All right, questions on any of the basic vocab words? Now I know it seems silly that I reviewed that because we've done that a lot in chapter 4, but we need these words before I get to the theorem that we have today. Okay, we good? All right, Pythagorean theorem, here it is. This is the main theorem. Once we go through this, we will do a proof, 2 proofs actually. So, in a right triangle, the sum of the square of the lengths of the legs is equal to the square of the length of the hypotenuse. It's a mouthful of words. There's a lot of vocab words in there. They use the word sum a lot. They use the word square. Notice not square root, but they say it's square. They use the word legs. Square again, and then hypotenuse. So there's quite a few vocab words. This is exactly the book, the way that your textbook puts it. I don't like it, but it's the main theorem in math that we can use. And again, it's in a right triangle, so it has to be a right triangle for this to work. Okay, as you're writing, I know you're still writing. What does the word sum mean? You're going to add. You're going to add, and they're going to eventually be equal to. So we're going to be adding the square of the legs. So when you square something, you put a little power of 2 on it. And that's going to be equal to, when you add those 2 legs together that are squared, that's going to equal the square of the length of the hypotenuse. So here's the picture I used earlier. Notice A, B, and C. The hypotenuse is always the letter C. The legs are A and B, and I don't care which one's A and B. Okay? So that's kind of your labels. So this is what the formula says. So in other words, A squared plus B squared equals C squared. You square the legs, you sum them together, you add them, and that's equal to the square of the hypotenuse. It's pretty much the most famous theorem in math. I mean, most people learn it in like junior high days. They just don't know why it works. A lot of people always try to ask, Ward, why do you have to square it? They're all squared. That's stupid. Just go A plus B equals C. You can't do that. Okay? So these squares have to be there. You have to take whatever that wall is and square it. Here's the reason why. Okay? Let's imagine that you are standing right here. Now this will hopefully explain it like common sense why you have to square these. And then I'll show you the proof why it works. Okay, so let's say you're standing there, and this is your house over here. So you're going to walk home. Okay, there's your house. Okay, you decide to walk that way, like straight path home. Okay, that's like the shortcut. You're cutting through backyards, you're walking straight home. If you're the person that believes like you can get rid of these powers of 2, like these squares, you're telling me, you know, a lot of people always ask, why can't you just go A plus B equals C? You can't do that because by you telling me this, that's telling me that if you walked around the corner, you walked around the block, you're walking the same distance as somebody walking the shortcut home. That's what you just told me. if you believe this is true. That you add the distances that you walked around the block, and that's the same number of steps as the shortcut home. That should never happen. Okay? So that's why you have to square them. It doesn't make sense when you see the picture. This is obviously a longer distance than somebody walking the shortcut home. So this doesn't work. That's why you have to square them so that it does make them equal. And now I'm going to try to prove that that's the case. Now, the only, so the way that I'm going to prove it is actually using your formulas that you just learned. So I'm going to show you that, but there's one thing we have to get before I start. We have to review one property before I actually show you this proof. The property I want to talk about is this. Now, this is going to seem a little silly. This is something we've done before, okay? This is adding like terms, right? Everyone knows what this adds up to be, okay? 3 plus 4, you get 7x's, right? But what we talked about earlier is when we were doing all the algebra stuff back in chapter 2, when we were doing proofs and trying to show why algebra things work the way they do and simplifying algebra problems. Does anyone remember the property name and how you're supposed to add these?
Substitution.
What? Say again?
Substitution.
Eventually it'll be sub, you are correct, that'll be like the third line, there'll be substitution eventually. But there's something in between.
Factor.
You have to factor things apart. Okay, what I mean by factor, you have to pull the item that they have in common out and leave the 3 plus 4. That's how you correctly add letters together, variables, right? You take the letter that they both have in common out of the back of it. It's called factoring or reverse distribution because they both have it, so you can pull that item out. And that's what you're left with. You're left with the 3 plus 4, which makes 7x. That's what makes 7x. So you're actually adding the numbers out front. You don't add the actual x. X is like a label. Okay? That property we need for this theorem to work. So if you can't wrap your head around that proof, why that seems to work, you'll never understand the thing I'm about to show you. Okay? And I did all the math on the board so you can see it. I'll be on the PowerPoint in case you didn't quite get it. But so let's jump right in. Let's talk about why this works. And it's going to use the theorems you actually just learned a little bit ago. All right, so here's proof number 1. This is the algebraic proof. This is the proof using the math that I've taught you the last couple days in here, especially what your homework is. Okay? So it requires knowledge of factoring and reverse distribution. So, okay, so the triangle ABC is a right triangle with the right angle being at C. So this is the picture I'm using. We're going to try to prove this. So here's the math that's involved. Okay, I'm going to show you the picture I've been showing you the last couple days in here. So this is the types of pictures you had in your homework, correct? Where they draw like a huge right triangle. They draw that little altitude. A lot of the times in your homework that you're trying to find B or you're trying to find A, you're trying to find this little stick or one of these pieces on the bottom. But it is a right triangle. It has the legs and it has that big hypotenuse. I just happen to label these parts on the bottom. Now, for this to work, I'm going to use the leg theorem, which was the, theorem 8.3 the other day that we did. So that's using like a leg, the part closest to it, and the full hypotenuse. So using 8.3, this is how it works. This is the leg theorem. That you can pick a leg, so I picked A and A. You put the part closest to your A, and then the full hypotenuse. Or if you pick the other leg, B, you go B and B, the part closest to B, and the full hypotenuse. That's the leg theorem. Okay? And to solve those, what you do is you cross multiply, and you set them equal to each other. So A times A is equal to Y times C, B times B is equal to X times C. That's the type of math you guys do in your homework. Now, here's my question. Because that's the normal math you guys have been doing all day, and that's what you do in your homework. What happens if I add these together? A squared plus B squared. If I actually add those together, you add A squared and B squared, because I can add anything I want, you would actually have to add these two things together. Okay, that's a property of equality. You can add equal things to both sides. So I would add these two things together, okay, right here. What do you notice that these have in common? The letter C. So it's using that factor rule. Like when I did the 3x plus 4x, I pulled the letter out back that they both had in common. So I'm going to pull the C out back, like that. So it's doing that reverse distribution or factoring, if you will. Now, I want you to look at the picture. What is y plus x on this picture? When you add y plus x, what do you get? You get the whole hypotenuse. You get letter C. I'm going to replace it with the letter C. And what's C times C? C squared. That's why the formula works. It's actually doing the math that you guys just did in your homework to prove it. So a squared plus b squared actually does equal c squared on any right triangle. Because again, that was just a generic right triangle. I didn't even know what the wall lengths are, but the math always works. And again, it's just using your leg formula. Okay, that's what you guys are doing in your homework, right? That, you know, maybe they gave you a certain number up here, and they told you this is 10 and this is 2. You can find the letter C by using these formulas, right? That's what you were doing in your homework today. So if you had to find the hypotenuse, you could set up your formula using your leg formula, right? This is a 2, this would be 10 and 10, because that's your leg, and the hypotenuse goes there. Because remember, it's the leg goes in the 2 spots, the part closest to it goes in 1, and the hypotenuse goes in the other. You cross multiply to that. Right, that would be 50. That would be 50. And then you can have this one, which would be 48, because 48 plus 2 makes 50. So you could find all the rest of the pieces. That's what you're doing in your homework. But this is the algebraic proof. Okay, questions on the first proof. I like it. It's very elegant the way it works. Again, I didn't give any reasons. This is more like the flow chart style. I didn't give you any reasons. All right, now let me give you the pretty picture looking proof. This is one that a lot of people like. Now for this next proof, the second proof, it requires that you know a little bit of geometry for area, for how you find area of boxes. So what I mean by area of a square. How do you find an area of a square? Like, how do I find the space on the inside? What do you do?
Base times height.
Yeah, base times height, or length times width. That's how you find it. Okay. So I want you to remember that. So to find the area, the carpet on the inside of this box, you take the base times height, or length times width. You multiply the two numbers together, so b times h, and that gives you the area on the inside. Okay. I want you to remember that. For this, I'm going to give you a pretty picture here. So, okay, so proof requires knowledge of rectangular area, length times width, or base times height, whatever you want to call it. All right, so here's the proof, and I give you a picture to go with this. So, the picture I'm going to show you is a right triangle. ABC is a right triangle, where the right angle is right at angle C. So it's that same picture I showed you earlier. I will explain this one as it goes. It kind of moves and it just repeats. I have it on repeat. So here we go, and it's going to prove the Pythagorean theorem. Okay, so ignore this. So here it goes. It's going to start with the picture right off the bat. It's going to start with our right triangle, and I think it cycles all the way through here. There it goes. Okay, so here's my right triangle. And I'm going to rotate it, and they're going to make a right angle up here, makes a right angle over here, makes a right angle down there, and a right angle. So it makes a huge box, and the area of this box is c squared. That's the whole box. And again, I'll explain this all. And all they're doing is moving the pieces around so that it makes the big box still. And when they separate it, it makes smaller boxes. So the whole concept here is that they're going to show you, they're going to take a right triangle and they're going to start rotating it. And the reason why you can do that is because the angles inside a right triangle, the two smaller ones, have to add up to be 90. So when they start rotating it, the angles do make 90s in the corner. So it is making a large box. And they're trying to point out that they're not going to get rid of this box. They're just going to simply move pieces around. So it's still the same area. The area hasn't changed yet, even though they're dragging pieces around. So it's still c squared as an area, but then they're showing you that I'm making small boxes here. Now why there's pink and blue in there? Because they're trying to show you the entire box. They're not trying to get rid of anything. They're trying to show you that all the pieces are still there. It's just rearranging it like a Jenga box. You know, putting pieces over like a Tetris puzzle. I think this is really kind of an elegant proof. It's using a ton of geometry, a ton of properties there. But it's trying to show you that you can prove it using pictures instead of just algebra, which I think is kind of cool. Okay, questions at all about the Pythagorean theorem? Okay, now tomorrow we're gonna look at an example of it. How do we work the Pythagorean theorem? What is it? Why am I teaching it now? Because it is quite useful. Okay. All right. The rest time is yours. You have about 20 minutes, almost exactly 21 minutes to actually work today. Okay, there you go.